Okay, so now we're looking at part B. So it says, what are the odds against drawing a blue marble? So again, when you have to look at the favorable and unfavorable. But since it says, what are the odds against it? We're going to put the unfavorable to the favorable. Okay, that'll make a little more sense. So the unfavorable, since we want to draw a blue one, the unfavorable are going to be all the other ones. Okay, so the yellow and the red. So there are 6 red and 2 yellow and 1 blue. So the unfavorable are going to be the red and the yellow, which are 6 and 2. So the unfavorable outcome is going to be the 8 marbles, because 6 plus 2, that are not blue. Okay, and then the favorable outcome, since we want to get a blue, there's going to be 1 blue marble. Okay, so we see that the unfavorable are the 8 not blue, because that's not what we want to get, and the favorable, which is the 1 blue one. Okay, so if we put it against, it means that we're putting the favorable against the unfavorable. So we want to put, the ratio is going to be 8 to 1. Okay, because the unfavorable is against what we want to pick. So it's going to be 8 not blue to the 1 blue that we have a chance of picking. Okay, now let's look at example 5, which is your last one. Example 5, Isaac has 6 blue and white shirts in his closet. There are also 2 pairs of navy pants and 3 pairs of khaki pants in his closet. So A says, what is the probability of Isaac will choose khaki pants and a white shirt from his closet? Okay, so first we need to find what would the probability be of him getting khaki pants? Okay, so we first need to look at the pants. So there are 2 pairs of navy pants and there's also 3 pairs of khaki pants. So if we have 2 plus 3, which is going to be 5, so we have 5 pants altogether. And the probability of him picking a khaki pair, since there are 3 pairs of khakis, the probability of picking it is 3 to 5. Now we're looking at shirts. Okay, and we want to find the probability of picking a white shirt. So there are 6 blue and 4 white. So that means that we have 10 shirts altogether. And then 4 of them are white. Okay, so we have 4 over 10 probability, which reduces down to 2/5. Okay, so they want to know what is the probability of him picking a khaki and a white shirt. So we need to multiply 3/5 times 2/5, and we multiply across. So we're doing 3 times 2, which is 6, all over 30, which can be reduced down to 1/5. That's wrong. Oh, sorry, that's 25, not 30. So the answer is going to be 6 over 25. Sorry, that is my fault. So 5 times 5 is 25. So the probability of getting a khaki and a white shirt is going to be 6 over 25. Now, if we look at problem B, it says, assume that after the pants and shirt are warm, they are put in the laundry hamper. What is the probability that he will choose khaki pants and a white shirt from the closet to wear the next day? Okay, so they're saying that he did not put it back into his closet, right? Because he wore them all day, and wearing the same clothes twice is gross, right? So he put them in the laundry hamper. He's not going to wear those again, which means we are down a shirt and down pants. We're also down a pair of khaki pants and down and now down a white shirt. So since we started out with 5 different pants, we are now down 1 pair. So now we're going to have the probability of khaki. We're going to say that's how you spell khaki. Is now we have 4 pants altogether, and he started out with 3 pairs of khaki, but he wore one. So now he has only 2 pair, which is reduced down to 1/2. Okay. Then the probability of a white shirt. Okay, so he had 10 different shirts, but he wore one, so now he's down to 9. And he had 4 different white shirts. Now he's down to 3 because he wore that one. 3 over 9 reduces down to 1/3. And we need to find the probability of khaki and white, which means I'm going